Let's solve this MCQ from Remainder and Factor Theorem. The question is, if a polynomial 2x square minus 7x minus 1 is divided by x plus 3, then the remainder is which of the following? So to recap what is remainder theorem, it states that whenever we are dividing a polynomial with another one, so we have a dividend and divisor. Now we have to look at the divisor. Here it is x plus 3. For what value of x is the divisor value equal to 0? I have to find that first. So if I have x plus 3, x plus 3 will be 0 when x equal to minus 3. Alright, now this value of x, which is minus 3, if I substitute in the dividend, which is 2x square minus 7x minus 1, and I evaluate, then that value will be the remainder. This is known as remainder theorem. So if I plug in the value of x equal to minus 3 in the dividend, I will get 2 into minus 3 square minus 7 into minus 3 minus 1. So this is 2 into 9 plus 21 minus 1. That is 18 plus 21 minus 1, which is 39 minus 1, which is 38. So 38 is the remainder after the division. So option B, 38 is correct. Now let us understand why this works. Why does remainder theorem work? How can we know that this is true? Anytime we are doing a division, whether it's numbers or polynomials, we always know that during division there is a dividend, and that will be equal to divisor multiplied by the quotient plus my remainder, if there is any. This is always true. So let's say when we are looking at polynomials, we have expressions with some variable, and the variable's exponent will be whole numbers. That is the meaning of polynomial. So when we are dividing polynomials, let's say that the dividend polynomial is f of x. This notation means there's a polynomial with variable x. And let's say the divisor is also a polynomial, which is g of x. The same variable x, but they might have different degrees. The dividend and divisors will have different degrees. And let's say there is some quotient q and some remainder r. So I will expect that fx will be equal to gx into q plus r. Now if I am able to find out a value of x for which the divisor is equal to 0, so if this is equal to 0, and let's say that value of x is equal to some constant or some number which is a. So for x equal to a, this divisor is equal to 0. Then 0 multiplied by any quotient is also equal to 0. Then we will find that this dividend is equal to the remainder. The dividend as in when I substitute x equal to a in my dividend, and that will be exactly equal to my remainder. So that is the meaning of, that is how the remainder theorem works. Now suppose if I was interested in actually verifying that this is true, let us also brush up our concept of long division of polynomials, because if we do that, we will still find the remainder. But the thing is, long division, in the name you know that it might be a lengthy process. So as a shortcut, we know we apply remainder theorem when we are only interested in finding the remainder. Now let's look at doing the division. The divisor was x plus 3, and the dividend is 2x square minus 7x minus 1. So when we are doing long division, we are setting up like this. Now the first term in my dividend is 2x square, and the first term of my divisor is x. So if I do 2x square by x, that is 2x. So my first term in my quotient is 2x, and 2x I am multiplying with the entire divisor, which is x plus 3. So 2x into x is 2x square, and 2x plus 3 is plus 6x. and then I'm subtracting this. So this is minus, this is minus. So 2x square minus 2x square is 0. It's cancelled. And minus 7x minus xx is minus 13x. Then I'll bring the constant minus 1 down. And then again, the first term over here is minus 13x, and the first term of the divisor is x. So minus 13x by x is minus 13. So minus 13 is the second term in my quotient. And I will multiply minus 13 with the entire divisor. So minus 13 into x is minus 13x, and minus 13 into 3 is minus 39. So I will see that when I subtract, minus 13 is plus 13 and minus 39 is plus 39. Minus 13x is cancelled, then 39 minus 1 is 38. So this is my remainder, and that's the same remainder I got by applying remainder theorem.